Now in this video I'll tell you about a fact that pushing is always tougher than pulling, and you must have heard this thing, and I'll demonstrate that why pushing is tougher than pulling. So let us suppose a situation that we are applying a force F at an angle of theta with the horizontal, and this is a pushing force which is acted upon on this mass M. And if this mass has a sliding tendency towards right hand side, then the friction will act on this mass towards left hand side. And let's suppose this friction which is acting towards left is F1. So now if I calculate this value of friction, then I have to find out the value of normal reaction first. So I am resolving this force F into two components. This component will be F sine theta, and this horizontal component will be F cos theta. So the normal reaction in this case will be equal to mg plus F sine theta, and therefore the friction acting in this case will be mu into n, and F1 will be equal to mu into mg plus F sine theta. So this is the friction acting in the case of pushing. But in the case of pulling, in this case, this is a pulling force which is acting in and direction which is at an angle of theta with the horizontal. So if I resolve this force into two components, so this component will be F sine theta, and this component will be F cos theta. Okay, now the normal reaction n plus F sine theta will be equal to mg, and n will be equal to mg minus F sine theta. Now this F2 friction will be equal to mu into n. If we are supposing that this block and this surface is same, then mu will remain same. Then F2 will be equal to mu into mg minus F sine theta. So which means that you can clearly see that F1 is greater than F2. So the value of friction in the case of pushing is greater than the value of friction in the case of pulling, and it is due to the fact that in case of pushing, one component of pushing force gets add up in mg to increase the value of normal reaction, and in the case of pulling, one component of pulling force gets add up into normal reaction and decreases the value of normal reaction. So due to the variation in normal reaction in pushing and pulling, this friction is varied, and the friction acting in the case of pushing is greater than the friction acting in the case of pulling. So therefore we can say that the pushing friction is greater than the pulling friction, and therefore pushing is tougher than pulling, because more friction is acting in case of pushing, and hence we require a more force to push and to move the block. So this was the concept, and I hope that you got to understand the concept completely. Thank you.